in width. And then we have our upper pylon where cables get connected. There are full number of cables that are getting attached. Then coming to the special features of the project, our main special feature of this project is the design. This innovative design is done in such a way that it can support its self weight independently, which would facilitate any kind of launching methodology. Can be used, like we can use both launching girders and bridge builder systems here. This would allow us to move forward. I mean, our cycle time for launching gets improved here, as cables can be attached on later stage. Bridge builders or the launching girder can move at the other pylon locations, and then subsequently cables can be attached at the later stage. This all, as I told, that all the spans are designed in such a way that the horizontal clearance is 125 meters and vertical clearance is 10 meters above HFL. So that helps for smooth and safe passage of ships and barges. We have implemented building information modeling here, which helps us in visualizing, helps us in better visualization of the structures, that improving overall efficiency and productivity of the project, such as we can place, we can tie rebar at precisely by looking at the BIM modeling of the project. Then coming to the challenges that we are facing in the execution, first is the meandering nature of river Brahmaputra. In our alignment, we have two main channels of Brahmaputra, two perennial channels of Brahmaputra that is running across our alignment. One is the north channel and another one is the south channel. So the north channel, if we look at when we entered into the project in 2021, that was 0.6 kilometers, but the boundaries were ranging from P79 to P84. But now if I look at the width of the river has remained the same, but the boundaries has changed from P83 to P88. So similarly in the south channel, if I look at when we entered, the boundaries were from P125 to P139, whereas now it has increased from P116 to P142, increasing the overall width of the project from overall width of the channel from 1.9 to 3.3 kilometers. Similarly, we have island in between these two channels, which we call as Birsing Island. So the Birsing Island also, the width of the Birsing Island has reduced from 5 kilometers to 3.5 kilometers. So that is the main challenge. From the logistic point of view, this becomes difficult as to in future if those well foundations will be there in land mode, or we need to do it by marine mode. So these challenges, fortunately, we have overcome, as we'll see that the substantial progress of foundation has been achieved. I was talking about the width of the channels. Now coming to the bed profile. Bed profile is also changing. I mean, year on year, if you look at these are the bed profiles. In December 2021, we had major 2 islands. Now in December 2024, we have 5 islands in between. So, it becomes really difficult to plan all our logistics every year. So, one mitigation was that to have the all-weather accessibility to our profile, to our alignment, we made 7 number of temporary access bridges. These temporary access bridges can carry a load of 150-ton crawler crane, both longitudinal and transverse way. A crawler crane of 150 metric ton capacity can travel through these temporary access bridges. So we have put 7 number of temporary access bridges along the profile, along the alignment. Total of 1.63 kilometers of temporary access bridges we have constructed. Coming to the viaduct foundation part, the main challenge in Dhubri side viaduct was how to retain the bore of 57-meter bore length. So we had to resort to specialized marine polymer. to stabilize the sides of the bore. And then coming to the Fulbari side there was a peculiar problem of rock socketing. We had a rock RQD value of more than 100 in Fulbari side. So according to our design specifications, we needed to have 8 to 12 meter of rock socketing in Fulbari side. So we implemented specialized hydraulic rigs of torque ranging from 235 Newton meter to 360 Newton meter. We deployed six number of such hydraulic rigs at the Fulbari side, and then we had to import multi-core barrels with roller drill bits to, go through these rock strata. And then in this pile cap construction, we had a typical challenge of inflow of water as we dug down to construct the pile cap. So in order to stabilize, we had to resort to sheet piling in various locations, and continuous dewatering we had to do in order to construct the pile caps. In substructure and superstructure part of the viaduct, there are 42 numbers such spans of in Dhubri side and 36 number of spans in Fulbari side, where it is coming over small channels over water. And the peculiar problem was that we cannot use our marine barges for bottom feeding of these launching girders. So we had to make some arrangements in our launching girders as to we can do the feeding from the rear. So we overcame this challenge by rear feeding by making some arrangements in the our launching girders. We have employed three number of such launching girders in our project. Some of the typical photographs of viaduct construction when during the construction period. Main bridge, main impact was, as I already told, the meandering nature of river Brahmaputra. Every year, we had this challenge as to, what foundations would be there in the water or what foundations would be there in land. So every year our planning was changed and dynamic planning we had to resort to. Fortunately, we have substantially completed our foundation part here. So we have substantially overcame this situation from the foundation point of view. And for deep water foundations, we had to do caisson foundations. One initial challenge was where to fabricate these caisson, as to because during the launching it needed to have enough draft. So we found a land from about 5 kilometers from the alignment where we could do this caisson fabrication, and we were able to launch these and taken to the location. Another thing was that while taking these caissons to the locations, we had to continuously dredge it as not enough draft was available all the time. These are some of the photographs of a bridge under construction, foundation under construction. Then main bridge substructure and superstructure. Our main problem was getting soil and getting precast yard of such huge dimensions at a single place. So that we could not arrange at a single place, and we had to resort to land at different places. Some of the photographs of superstructure and substructure in construction during construction. These challenges I have already covered up. Apart from that, we have this bridge comes under seismic zone of 5. So design had to be such a way that it takes care of that. Also, this being a remote location, we had to plan early so that mobilization of equipment can be done, can cater to the lead time due to the remote location challenges that it is posing. And coming to the project progress, physical progress is 60.56 as on date. And we can see that the substantial on that foundation and substructure has been substantially completed for both main bridge and viaduct. Now segment casting and erection is going on in full swing. Major materials and resources, these are some of the major materials. Scope is 8 lakh 7.58 cubic meter of concrete is there, and 1 lakh 10,000 odd rebar is there. And we can see that we have completed about 60% of these. These are some of the major resources that we have deployed here, ranging from launching gantries to transit mixers. And staff, we have about 289 number of contractor staff, about 2,200 odd workmen is there. And then from authority engineer, we have about 53 numbers of staff. Coming to the benefits, as I've already touched, this would definitely increase the socio-economic development of this region. And also from the environmental benefit, this would reduce the carbon footprint as the distance would definitely reduce. Now I'd like to have a brief glimpse of the project.
Please conclude within 3 minutes.
Okay.
Welcome. To start with, we did the groundbreaking ceremony on the 20th of January, 2021. After that, we did detailed geotechnical investigation and topographical survey. Initial pile load test done on test piles to confirm the capacity of the piles. Here are some of the glimpses of viaduct piling and substructure works. These photographs capture the core stages of our project's well foundation work. Next, the caisson fabrication highlights the meticulous process of creating these massive, watertight structures. Then comes the caisson launching, a crucial and challenging phase where we transition from land to water with exact coordination. Here are the glimpses of viaduct segment casting yard. Once ready, we move to viaduct erection, lifting and placing the segments into position with precision. Then, we focus on main bridge casting, where larger, more complex segments are formed to handle greater loads. Finally, the main bridge erection brings it all together, assembling the core structure that connects the entire project. Now, let's take a bird's eye view of the project, showcasing the full scale and progress. This is the 0 point of the Dhubri-Fulbari Bridge project. Here, we are 43% of the segment erection has been completed in this section, marking significant progress. From here, the main bridge section starts, extending from P60 to P160. Right now, we are at the P60 to P78 section. In this section, work is actively ongoing on the pier table, segment erection, and the upper pylon activities, which are crucial steps in the bridge's construction process. There are two main navigational channels in this river, the North Channel and the South Channel. Currently, we are at the North Channel. There is an island between the two navigational channels. Currently, we are at the island where we have two casting yards. All foundations and substructures on this island have been completed, and work is actively ongoing on the pier table activity. Currently, we are at the South Channel, where foundation and substructure activities are ongoing. We are at the Fulbari side of the main bridge section, where pier table activities are currently in progress. Currently, we are at the pile foundations of the main bridge section, spanning from P154 to P160. All the piles in this section have been completed. From here, the Fulbari Viaduct section begins, extending from P161 to AB02. All foundation work for this section has been completed. Segment erection works of Fulbari Viaduct are going on OHS. 20% of segment erection has been completed in this section. This marks the end point of the Dubri-Fulbari Bridge project.
Thank you, sir. Thank you for your patient hearing.
Thank you, Mr. Deshmukh. It's a wonderful presentation and excellent case studies. I think after the end of all presentation, we'll discuss these issues. Now the next speaker is again a case study on construction aspects of 6-lane extradose bridge over river Brahmaputra by Sri Madhav Singla, manager project from SP Simla Construction.
Excuse me, it's not presenting. Yeah. Okay, fine. A very good morning to respected chair and co-chair members, distinguished dignitaries, speakers, and all the delegates present over here today. The topic of my presentation is construction aspects of 6-lane exodus bridge over river Brahmaputra. The bridge is being constructed by SP Singla Constructions Private Limited. This is the 3D night aerial view of the bridge, and you can see the facade lighting. The location of the project is where we all have gathered today, Guwahati itself, and this bridge will connect South Guwahati to North Guwahati. This is the key map of the project. The project starts from the Bharlumukh at South Bank, and there's a main bridge in the river. After that, there's a North Viaduct highway, which consists of minor structures as well, and it connects NH31 at the Gauripur junction. The foundation, the total cost of the project is 2606.68 CR, which includes the cost of land acquisition as well as authority engineer. The project is funded by NDB. NDB is funding 80% of the project cost and 20% of the project cost is funded by Assam government. The appointment date was 14th August 2019. The EPC contract value is 2187.03 CR. The scheduled completion date was 13th August 23, but due to certain reasons such as COVID and extended monsoon period, we are expecting the completion of project by the end of this year. The structure consultant is Vicon Consulting based out of Taiwan, and structure consultant for South Flyover, North Viaduct, and highway portion is ASC based out of Noida. We also have an independent design checker in this project who is B&S Engineering Consultants, Noida, and authority engineer is Sistra Brazil. These are the project components. The project includes South Bank Corridor, which is a 3-lane one-way flyover, and it is a PSE box girder type structure with a span arrangement of 50 meters. Then there is a ramp with a span arrangement of 100 meters, and these are 2 ramps, east and west ramp, with a total length of 719 meters. Then there is main bridge, which is a 6-lane bridge. It is an exodus bridge, and it has a span of 200 meters with side spans of 120 meter, making the total length to 1240 meters. Then there is viaduct, which is of 800 meters, and these are 2 parallel carriageways. There is a highway, ROB, rotary, service roads, box colored VUP, and a minor bridge. So this is the general arrangement drawing of the structure portion. There's a south flyover on the left side, you can see. Then there's ramp, east and west ramp. It is a balanced cantilever type of structure. There's a main bridge, and there's a viaduct, which are two parallel carriageways. So these are the design parameters. The discharge charge is 81,000 qmax, and recorded highest flood level is 51.46, but we are designing it for HFL of 52.3. So the navigation clearance from the HFL would be 13 meters, and average founding level of the well foundation is around minus 14.4, with a grip length of 23.6 meters. So this is the current progress of the project. As you can see, we have completed main bridge up to 94.61%, north viaduct 97%, south flyover, which it was already handed over last year, and there's a ramp. So currently we are at 90%, and we are hoping to complete it by end of this year. So this is the bird's eye view of main bridge. So starting with geotechnical investigation, GT investigation is important, which helps to understand the foundation requirement of the construction. So when we performed the GT investigation, it was revealed that at PY1 and PY6, at both locations, the rock level was at much higher level. So we had to go for pile foundation at these two particular locations, whereas the rest four locations, PY2 to PY5, well foundation was adopted. These are the borehole locations of the GT investigation. So starting with the foundation of the main bridge, uh, pile foundation had a diameter of 2.5 meters. It is one of the largest diameter piles being executed in India. So there are total 20 number of piles in each group. Working load on each pile is 1700 metric tons. So a special kind of equipment, which is BG39, which are very few in India, was used. So the hard rock where the drilling was being done had a UCS of more than 100 MPa. So due to hard rock, the rate of penetration was very slow, very time consuming and energy consuming. So we also faced some of the challenges, like while drilling in the rock, the Kelly got teared. So we had to replace the Kelly and importing it from Malaysia. And the piling tools, this is a roller bit, which is made up of tungsten, one of the hardest material, but it also used to worn out, and we have to replace it multiple times during drilling in one pile. So this is the load test on the pile. Initial load test was performed using BDSLT method. So BDSLT method helps us to separate the soil and rock resistance, and to record the movement of the shaft and the toe. So the optimum position of the hydraulic cells is identified such that failure does not occur in one direction prematurely. So the total test load on the pile was 5,000 metric tons. We observed the settlement of 13.6 mm at PY6 and 4.6 mm at PY1, and to check the integrity of the pile. The results are very good. Coming to pile cap, the pile cap dimension was 22 meters by 23 meters. So the total quantity of concrete was around 1620 cm, which is a very huge quantity. And to avoid the cold joints, we had to maintain a good pouring rate. So with a pouring rate of 50 cubic meter per hour, we completed the pouring in just 32 hours. There was also a huge reinforcement, which was around 250 metric ton. So as both pile caps, PY1 and PY6, were on the island, so we had to complete this activity before the onset of monsoon season. And to complete the concreting, we used 3 batching plants and 3 separate boom places were used. A proper shoring arrangement was done, and the concreting was achieved successfully. Coming to well foundation, the average depth of well foundation is around 58 meters. It is a double D type of well with dimensions 18 meter by 10 meters. And the water depth at all the 4 locations varied from 8 meters to 25 meter, with 25 meter being the maximum PY5 location. So we used special kind of machinery such as higher capacity cranes to expedite the sinking process, and the whole process, whole well foundation was completed within a year and a half. So you can see fabrication of caisson. The total height of the caisson was 6 meters, and there was also a huge quantum of steel. The total weight of the caisson was 120 metric tons. This is the floating sequence where you can see, first of all, the caisson is fabricated at a yard just behind the jetty area. Then it is bring into the position in the reach of Goliath gantry by using a 250 metric ton crawler crane. Then before floating the caisson, we had to check the availability of draft at the jetty location. We needed to have a sufficient draft, but since it was a lean period, the draft availability was quite less. So we used dumb barges to reduce the draft requirement. This is how the caisson is being lifted using the Goliath gantry and floated into the river. Then the caisson is towed to the desired location using the tugs. We use 1000 bhp tugs to complete this job. And this is the tethering arrangement. Due to the high water current, we designed the tethering arrangement. We designed it for a water current force of 80 tons to stable the caisson into the river. And then successive successive modules of the staining were joined on the location only. We fabricated different modules of staining at a fabrication yard. We transported them to the river and joined them together at the site itself. Coming to the substructure, the height of the pier is 19 meter with dimensions of 8 meter by 5.2 by 19. Then coming to the segments of precast segment, this is the casting yard layout. Due to huge quantum of segments, we needed a area around 9.6 hectares, but it was not available, so we developed the casting yard in the ROW itself. We developed two separate casting yards, casting yard 1 and casting yard 2. Casting yard 1 was for main bridges and casting yard 2 was for south flyover, north viaduct and some of the ramp segments. So total 7 number Goliath gantry cranes were used. This is the casting sequence where the rebar cage is being assembled together and then it is lifted and put it into the mold. Then we do the profiling, form work, and then do the concreting. After that, the molding is done, and after the casting of the next segment, the prior segment is lifted up and stacked to the location. So total 5 molds were deployed. The total fabrication quantity was 826 metric tons. The width of the segment is 33 meter. It is one of the widest segment in India, and each segment had a weight of 180 metric ton. This is the total quantity of segments, where you can see main bridge has 403 segments, north viaduct 576, and south flyover had two type of segments, single cell with inner strut and double cell segments. So, and there are some unbalanced segments of the ramp portion as well. So total number of segments were 1340 segments. So these are some of the crucial points which have to be taken care while casting of the segments, such as site logistics. First of all, adequate space is required for stacking the precast segments, and then quality control. It is very much important to maintain high standards of quality during the production of segments. Otherwise, defects can lead to significant issues during assembly. Alignment and geometry control is also a very important factor since all the segments were casted on a short line method. So geometry control becomes more important in this particular casting process. And then handling and loading and unloading of segment is also an important criteria which needs to be taken care of. Coming to the superstructure, you can see the casting process of pier table. Pier table is casted monolithically. The pier table is casted in two stages. Stage number 1 with soffit and web of 2 meter height and remaining in the stage 2. The total steel is 180 metric ton and concrete was around 470 cubic meter. So the total dead weight of the pier table was 1300 metric ton. This is the supporting arrangement of pier table which was used. Now coming to the stability during construction, since this is not an integral pier, so it was important to anchor the complete cantilever with the pier. So for that, temporary fixing arrangement was done. For that, we did some checks regarding the construction forces. These are all the construction forces which are considered during the design. And these were the compressive strength and tensile, compressive force and tensile force which was being coming to the structure. And we put around 200 PT bars to hold down the structure during the complete erection of all the segments of one pier. This is the bearing layout. From PY1 to PY6, all the piers have friction pendulum bearing. It is also the bearing which is being used first time in India. It is a seismic isolation device, which I'll explain later. So coming to seismic isolation device, since the structure is a continuous structure, which means expansion joints are at a distance of 1240 meters. So it is a continuous structure of length 1.24 kilometers. So due to these high temperature forces as well as seismic forces were coming, which needed to be reduced so that substructure and foundation had a much lesser forces coming from the superstructure. So therefore, dissipation of energy was required. For that, seismic isolation device was used. These are the specifications, like there were 4 bearings on each pier, and these are the loads which are coming. The bearing is designed for a maximum vertical load of 7,800 metric tons and a maximum horizontal displacement of 249 mm. The bearing was tested in Italy. There is no testing facility available to do the testing of complete model. So there was a prototype was made with a scale of 1:2, and the results were found to be okay. These are the testing parameters. All these testing parameters were fulfilled. Coming to the installation, the bearing is installed using platform. Since the bearing weighted 8 metric tons, a special kind of platform was made so that the bearings can be installed successfully. Wind tunnel test of the structure was also performed. The model ratio was 1:100, and the wind tunnel testing was performed in Taiwan. This is the model expansion joint. It is a 8-cell model expansion joint with the opening condition displacement of 376 mm and a closing condition displacement of 264 mm. It also has a seismic fuse. Seismic fuse is used to isolate the joint from structure during earthquake. This is the main bridge cross section. So it is a 6-lane, so that carriageway width is 12.5 meter on either side. The total height of the pylon is 32.25 meters. These are the dial links which are used. Dyno links are casted while casting of dyno links are put while casting of pylons. Stay cable are anchored. Stay cable is not continuous, so it is anchored at both ends of the dyno link. These are the specifications of the stay cables. There are total 11 stay cable in each pylon on one side. Number of stands vary from 75 to 103, and LRP is 15.7 mm with HDP coated. The total weight of stands used in the project is 988 metric ton just in the stay cable. If I talk about South Viaduct, North Viaduct, then there's total around 3,500 metric ton of HT sand which is being used. Coming to the erection of superstructure, first of all, the bridge builder is erected. This is a sketch of bridge builder. Now, these are the construction stages. First of all, the bridge builder is erected. Then the segment is transported. Then segment number 1 is erected. There's a stitch between segment number 1 and pier table. So after casting of stitch, auto launching is done. Next segment is erected, and so on. You can see the photograph of loading of the segment on a self-propelled barge. This barge was specifically deployed for this project. It has a capacity of 800 metric ton. It was deployed so that we can work during high water currents as well. This is another photograph. This is how the segment is lifted when the barge is positioned at the pier location. This is when this PY1 is in the island area, so the segment is transported via river and then transported by land on the trailer. So first of all, dry matching is done after lifting of the segments. So geometry control is again a very important parameter in erection of segments. During erection of segment, at every stage, we do the geometry control so that the actual profile matches with the pre-camber. And if there's a deviation, we take corrective measures such as shims or vestige in any case. It is important for the both cantilevers to meet at the mid-span at the same elevation. So epoxy application is done. Epoxy should be oozed out uniformly. This is the temporary pre-stressing at the soffit and at the deck level. Then longitudinal tendons are stressed and grouted after 24 hours. This is the stay cable installation and stressing sequence.
Please finish within 2 minutes.
The recess pipe is casted during segment casting, anchorage is fixed, stay pipes are butt welded, and this is installation of the HDP at 4 number point. Then cables are installed, stressed together. Then after that, auto launching is done. So coming to mid-span closure, when erection of all the segments is complete, we do the mid closure. For that mid segment, closure segment is erected and a vestige is cast on the both sides. This is jack apart. Jacking apart is done to push both the cantilever so that compressive stress is induced in the deck. So once the jacking apart is done, the maximum force of the jacking part is 800 metric tons for the displacement of 119 mm. So once we push the decks apart, we do the casting of the wet stitch. After casting of the wet stitch, we install the longitudinal tendons and activate the frictional pendulum bearings. This is the activation process where these M80 concrete blocks have to be cut in a sequential manner so that the load is transferred uniformly onto the FPBs. This is the construction of unbalanced span. The unbalanced span is of 20 meters. You can see on the side, these are the side span, which is 120 meters. So for that, we construct a temporary tower. For that, steel temporary towers are designed and constructed below segment number 31, 32. And then hydraulic jack is used to jack up the cantilever. We put a force of 167 metric ton. And then bridge builder goes on and lift the successive segments. So this is a very important activity, and monsoon season poses a serious challenge in planning and construction of this activity, as this has to be complete prior to the monsoon.
Mr. Madhav, please conclude.
Yes, I
We are
just need
running
2
out of
minutes.
time.
Yes, yes. So I would like to play a time-lapse video of segment erection. Just. So that was time-lapse video showing the reaction of the segments. Coming to the ramp, there are east and west ramps. These are balanced cantilever ramps. This is the bird's eye view of east and Y ramps. So this is the CLC gantry which is being used to cast in situ the balanced cantilever segments. This is the GAD of ramp portion. It has a span of 100 meters and the expansion joint is at PL1 and PL5 only, and it is continuous for this complete span. And this is the various stages of cantilever construction. First of all, the pier head is casted, then the gantries are erected, then first segment is casted, and then the auto launching of gantries is done. There's this sequence of unbalanced span erection. It was done using 600 metric ton cranes. This is South Bank flyover. It was handed over and was inaugurated by Honorable CM of Assam on 4th March 24th. This is the North Viaduct. North Viaduct was constructed using launching girders. We also use underslung method, like 17 spans were uh, done using two sets of underslung and 25 spans in the north were done using the underslung method. This is how the underslung is being performed. Then there's additional scope of work which is BHMS. BHMS is used to measure various kind of strains, displacement, vibration in the bridge. Then we are going to do facade lighting and anti-carbonation painting of the bridge as well. There are some challenges. I think the challenges will be covered in detail in the next session by Das Gupta sir. But these are some of the challenges like COVID-19, unprecedented increase in the water level in Brahmaputra River. This is the case which gave us a major setback because when we were doing the pile cap of PY1, a premature increase in the river water level was observed and all the work was hampered. Then we have to start again by taking out all the enforcement, putting in new enforcement in the next season, and pile cap was done. This is how the water level was increased in that particular season in 2022 in the March. Then there are some geotechnical conditions
Please
as well.
conclude. We are
Yes,
running
I'm
out of time.
completion. Yes, sir. So this is how in between season and monsoon period affects the work and environment related measure, environment related challenges also because we have to do the construction by keeping in mind the aquatic biodiversity and dolphins in the river. Okay, sir. If you permit, I would like to play animation. Just a 1 minute animation is there.
Okay, okay.
So this is the project walkthrough. I'll These are the ramps, and now this is the main bridge. This is North Viaduct.
Okay, thank you very much, Mr. Madhav Singla. So, very excellent presentation. The next speaker is Professor Ravi Sinha from IIT Bombay. Professor, he is there. So, he's going to talk on new material technology in construction of bridges.
Thank you. First of all, I want to express my thanks to the organizers, the IRC and the Government of Assam for inviting me here. Uh, I'm going to be talking about something which all of you are very familiar with, that if you want to do a project fast, or if you want to do a project which has complicated elements, then two things happen in India all the time. First of all, variation after variation. Second is dispute after dispute. So these are the two characteristics irrespective of the project. And that is because so many changes have happened in the entire paradigm of bridge construction which we are not yet adopted in India. So I want to present to you exactly where the world is with respect to bridge constructions, and that is known as accelerated bridge construction. So I'm not going to talk about a particular material or about a particular technology. but about a combination of materials and technology which gives you a totally different class of delivery of the final product, which is the bridge, compared to the current status. So the new paradigm, it is known as accelerated bridge construction. It has many, many new things, many different things are together. But when it comes to talking to the client, so the ministers, the people who control the finance, then the thing which is easiest to talk is that your bridge is going to be completed faster. So that is why the name has been given as accelerated bridge construction, but acceleration bridge construction is an outcome. It is not the starting point, it's an outcome of how the things happen. So ABC, which is a short form of accelerated bridge construction, it permits the completion of the project in a much shorter life cycle, and it takes into account the decisions regarding during the design and construction appropriately. Then ABC also allows us to take into account factors such as congestion during construction, impact on environment, etc., during the design and construction process. And it uses a combination of innovative materials, innovative technologies, and processes to meet the project objective. And as I mentioned, that the result is a much higher bridge delivery. So that is why the name has been given as ABC. So ABC actually is the future of bridge projects all over the world. India is a little bit lagging, but it has to catch up. So it is the most comprehensive framework that ensures long-term performance, resilience, and sustainability. And it can also be used for the non-bridge parts of the infrastructure projects, like the rigid pavement and so on. So ABC uses one or more of the following: innovative planning, innovative design, innovative materials, innovative construction method and equipment, and lastly and most importantly, innovative management practices. If you want to do a faster delivery of a project or a more complicated project using the management style which we currently have in practice in India, then the end result is going to be what all of us are familiar with. So it also requires an innovative management practice, and I will show some examples. So what does it do actually? I'm just telling you the key points of the advantages. It improves site constructability. So all the pain points which you are familiar with, you will see that all of them get improved. The site management improves, total project delivery time reduces, material quality improves, project durability improves, work zone safety for both the people as well as for the construction project workers, that improves, congestion and pollution reduces, and sustainability is enhanced. All of them are having, these are all the typical key points which we have to take into account during our project delivery. So it reduces the traffic impacts, on-site construction time, site-related delays due to weather, etc. We saw one example just in the previous presentation of abnormal water levels and all. They can all be anticipated and mitigated using the ABC framework. So the kind of picture I'm seeing, these become much shorter duration or are eliminated altogether. Then the environmental impacts are minimized, existing roadway alignments can be less disturbed, and the utility relocations, the right of the way requirements, they all become simpler. So let me give you an example of delivery of ABC in projects around the world. So this is a bridge in Montreal known as the New Samuel de Champlain Bridge. It's about 3.3 kilometer long, and including the main span of 529-meter cable stayed bridge. And so 3.3 kilometer constructed in 48 months, 4 years, in spite of the fact that 5 months in every year, the construction cannot go because the whole area is filled with ice float. So basically 7 months a year is your lean season, and delivered in 4 years out of that, 3.3 kilometers, including cable stayed bridge of more than 500 meters. So just compare that with the delivery time which we see in the projects around us. So the project used ABC framework, and now in terms of the details of the project itself, it has 3 independent carriageways 3-lane plus 3-lane carriageways for the road traffic and a 2-lane metro line. So it's a fairly complicated. Not only is it a long bridge, it is also with 3 independent carriageways and so on. So ABC was used in the lower pylon construction. So total pylon height is 170 meters. The lower pylon height is 55 meters. And that entire 55 meter, including the foundation, was completed in 40 days. So just one example of how you are able to achieve faster construction. Another example is what is known as FM 849, a viaduct in the US. So it is on one of the highways in the state of Texas in US. And this was an existing bridge which the underway, an oversized cargo hit it. And because of that, the bridge was severely damaged from below. And it had to be replaced at the earliest and also at reasonable cost. So this accident happened in November 2017, not long ago. And within 1 week, it became clear that using conventional method, you cannot reopen the bridge quickly. So it was decided to use ABC. And 2 weeks after that, in the first week of December, the reconstruction started. And 3 months later, the project was open to traffic. Another bridge is the Franklin Avenue Bridge. So there was a historical bridge which was constructed in 1923, which is also listed as a historical heritage in the US. This is a photo of that bridge. The superstructure was badly damaged because of age and also because the traffic pattern had changed entirely from the time it was initially designed. So the entire superstructure had to be replaced. A little bit similar to what we have seen in the Gandhi Setu bridge in Patna, where the entire superstructure had to be replaced. But in terms of the outcome of how to do and how much time to do, the story is totally different here. So this is what it looks like now after the work has been completed. And again, using ABC. So extensive use of ABC framework was made. And the total replacement, instead of 2 years using the traditional technology with the most you can say, rapid construction methods in place, instead of that, it got reduced to 4 months. So huge benefit from 2 years to 4 months, reduced traffic impact, reduced on-site construction, improve safety, improve constructability at site, improve material quality, product durability, minimize environmental impact, and also reduce the life cycle cost. Actually, it was less expensive to use ABC compared to the construction technology and everybody fighting with everyone to add the extra items. So how can we achieve all these things? What do we have to do if we want ABC? So a number of aspects. It's a new paradigm. So you cannot do one small thing here or one small thing there and become ABC. You have to change the entire approach towards a bridge project, starting with the selection of engineering team. If you want that the current engineering team, with the style in which they are used to working, are going to deliver ABC, it will not happen. It may be the same team, but the style of delivery has to differ entirely. And obviously, if you want to do things fast, then on-site construction has to be reduced. So from planning stage itself, we try to move as many activities off-site as possible. So because of that, we have to use prefabrication in a big way. So we have to use the prefabrication methods which are more advanced. We need to transport, again, to reduce the on-site activity, we need to transport longer segments if required. Then at the site itself, we need to use more high-capacity equipment. And we cannot do the typical style of the contractor taking all the responsibility and nobody else really having any skin in the game. It has to be a joint effort of the contractor and the consultant. The authority engineer and the contractor have to be jointly responsible. So that's part of the new management. And all the other examples I showed you, they are all government-funded projects. They're all government-owned projects. But they have all been doing it. And so are hundreds of other projects around the world at this time. Then the labor may require new training, particularly if new equipment is being used. And the progress inspection techniques, etc., have to be changed. So one of the key things to remember is that using ABC requires heavy upfront expenditure in infrastructure. So the way mobilization advances are done and so on, they also need to be changed. So maybe you have a special, you have the typical mobilization advance, and then you have a special equipment advance, which can be amortized, say, over the first 4 or 5 RA bills or something like that. So there is a well-developed procedure, the step-by-step procedure on how we implement it. And people who are interested can go through, documents are also already available on the way. But it's not science which is very complicated. It's a standard, conventional management practice for any new technology. So when we change from landline telephone to mobile phone, all of us, without realizing, adopted this. Somebody had to produce a mobile phone and bring to us. And now you are the one who's going to bring the mobile phone equivalent, which is ABC, for the bridge projects. And there are certain kinds of projects where it has been demonstrated, again, in a large number of projects, that they are very advantageous. And so it is very clear that when we have these kinds of projects, then ABC will be actually less expensive in the life cycle over and above delivering the project much faster. Now, how does it compare with the conventional bridge construction? So first of all, both of them need to have the same design criteria. They need to be designed for the same traffic load, same environmental load, and so on. But ABC also requires, because of the construction method, that they have to be designed for different type and different magnitudes of construction load. Typically in ABC, we find that the superstructure design is governed by the construction equipment load, not by the traffic load. But even then, it is less expensive. Just keep that in mind. So management practices, as I mentioned, need modification. Why it becomes less expensive is because we have better control on what we are doing. So because of that, we can reduce the self-weight. And because we reduce the seismic forces, so the substructure and the foundation becomes less expensive. Because the superstructure weight, if it reduces, the seismic force reduces, and that has benefit in the substructure cost. So overall cost reduction is there. And we can, when it comes to precasting, it is up to us, depending on the requirement, whether we can have only the deck elements or the beam girder elements or the pier elements or the walls, abutments, or what all we want to do precasting in the interest of the project. So this is particular, for example, one particular example from Puerto Rico, that there was a bridge which was replaced, and it was made into a fully precast replacement after the original was demolished. So 4 viaducts, each ranging in length from 200 to 275 meters, were constructed, and each viaduct was constructed in a 24-hour cycle. This is what it looks like after the construction was over. So one day, people went to sleep, and the area was cordoned off. Next day, they went to their offices, came back, went to sleep again. And the day after that, when they opened up, they had this gleaming bridge with all this traffic in front of them. That's what ABC was able to deliver in this particular project. And the cost was $2 million less than the lowest using the conventional technique. So not only was it faster, it was also less expensive. Another example is the Confederation Bridge in Canada. So this particular bridge, so here again, 5 months a year, you cannot do anything because the whole thing is snowbound. And fully precast bridge was the only option. They decided to go one step forward and decided that they would construct this as a fully precast bridge using ABC, not using conventional management technique. The total length of the bridge is 12.9 kilometers. So you can imagine how long the bridge was. And we just had an example. We had 2 examples of very extended construction time period. Now you compare that with this particular bridge, which was nearly 13 kilometers long and constructed in 3.5 years, when 5 months a year you cannot be in that area because of the snow. 7 months a year, you are constructing 3.5 years, the bridge is ready and delivered. The bridge design life is 100 years, just like we have in India. And it was only because of ABC framework that this bridge could be delivered. within the intended time frame. So ABC represents a paradigm shift. So it's not just doing something better here, there, and so on. It's a fundamentally different paradigm because the management system, the management thinking has to change in order to deliver ABC. So it's a paradigm shift, which means that the vision and way forward for adopting ABC has to be decided or has to be, you can say, conceived and not just make tweak here and there. So the question is that in India, so in other countries of the world, I'm showing ABC. In India, do we have the capacity as a society to adopt a new technology to deliver what we are very familiar with? And I want to give the example of automobile sector because we have done that already. So many over here will remember this is what automobiles used to look like. So if you look at the automobile industry from a few decades ago, incidentally in the manufacturing segment of the economy, automobile was the largest contributor. It was the most prestigious, most high-tech, most high-profile industry in India. And this is what it used to look like. So we had two major companies plus a smaller company, and they were the pride of the nation, and they were meeting all our mobility requirements. So this is what it used to be. Before the ABC equivalent of the automobile industry came in there. Then it changed to this, again producing automobile, again for mobility, not doing something new, but a new paradigm. And your manufacturing system became something else altogether. So in India, we have done that. If the same people had the capacity to change, they would be doing it. If the same people who were doing it earlier remain stuck in their historical mindset, then of course they get replaced by new people. So both the past and the present in the automobile industry, they are capable of products which meet the need of mobility. But the overall performance you can see in terms of the fault rate, in terms of the durability, in terms of the number of times you have to go to the garage for maintenance and so on, they all changed drastically when we went from the old technology to the ABC equivalent of the automobile industry. So in accelerated bridge, in the bridge industry also, we can use accelerated bridge construction to have a similar paradigm change in the final delivery. So what's the way forward? First of all, my contention is that adoption of ABC is inevitable.
Professor Sinha, please conclude in 2 minutes.
Yeah. In India, if we are not capable of doing it with Indian companies and with the Indian industry, all of you over here, somebody else will come and do it for us because society would expect better. So society needs, they always overcome the desire of not changing by the industry. So just like in the automobile industry, even in the construction industry, this change is inevitable. So either we have our industry, all of us changing, or we will fade out and new ones who are doing it elsewhere will come and take over. So thank you all.
Thank you, Professor Sinha. Now the last presentation of this session is again another challenging construction practice, launching adders by Kaustubh Ghosh from L&T. Modern bridge construction with launching issues.
Is it okay? No, it is. No, this is not. This you cannot because there are videos. This is not. This is a PDF one. Please quickly connect because I have to make some changes in the laptop because there are certain data which I cannot transfer. So you have to bear with me for a minute or two. In the meanwhile, thank you, sirs, for giving me an opportunity to be here. The IRC management. Is it audible now? Because I was hearing too much of reverberation, so I was trying to be back. Is it okay now? Yeah. I will take both. Is it audible now? Not so. Is it fine? Fantastic. So good morning, everybody. I thank the IRC management to give me an opportunity to be here, and also the speakers, those who delivered beautiful speeches, and all of you eminent professionals by virtue of your own achievement. While preparing the presentation, I was just running through what I should tell. Is there something which I'm going to say which you already know? Probably yes, because we cannot ignore any of the data. Today, when you talk of modern, it is basically the paradigm shift has happened opinion-based, experience-based to data-based. So what are the data you are capturing? And all these are having gruesome impact in the whole process of design, delivery. So I just thought it would be nice that we rekindle ourselves with the data. What are the types of bridges? These are all known to you. But having a run will not be making much of a difference. So these are the options what we have. The last one may be a little bit new, and I will take you through that. The design philosophy, still it is either cast in situ, or precast, or prefabricated. Major equipment, hoisting equipment, and movement equipment. Because there are two movements happen, one is horizontal, one is vertical. Now, what are the basic things it takes care of? One is structural integrity, compliance with the standards. Prerequisites are there because approvals, there are interested parties, there are governance, you have to go by that. Specialized resources, which are slowly eroding because this particular industry is not so glamorous and more challenging. Coordination and logistics, safety considerations, quality control, because what we will be doing, probably generations after will be using it when we are not around. So our response is quite some factor more. And last but not the least is environmental social governance, which is about the existence of human race in the world. I will just, 1 minute. I think this is not. No problem. I intentionally wanted to switch that because. Now our topic is about modern launching gantries, or how do we do the superstructure. I'll focus on that area because other parts have been already talked by the other speakers. Now, what are the types of launching we have? One is overhead, one is underslung, and then we have tandem lifting, we have balance cantilever method, we have full span launching. Full span launching is a very recent part which we did during the high-speed railway. A lot of you might have seen, a lot of videos have been posted. Overhead LG, underslung LG, they're very common today. But even though they are common, there are a lot of safety features which are getting added to in order to make sure that there is no safety hazard coming in. And it also takes care of the risk level imposed by the skill set deficiency currently in the market. There are the equipment which are being used, crawler cranes, tower cranes, stand jacks, trailers, pullers. These are all known to you. Now, what is the advantage of overhead LG? As you are aware that it is minimum ground disruption because the habitats are there. There could be a lot of infrastructure coming in under. It has got a high-speed construction because it is not being challenged by the other logistics. The equipment itself is reusable. That means the owner who is owner of the equipment can make use of it multiple times. This is adaptable for different spans. That means if the configuration changes, you can do it. It has got a precision. And at the end of the day, the person who is doing business, he also wants to earn money, so it should have a cost efficiency. What are the challenges? It is quite high investment if you want to go for a better launching entry girder. It is a bit complex assembly and dismantling when it comes to the latest engineered launching girders. This requires high-skilled crews, considerable self-weight, because that plays a vital role in the designing of the structure, because the structure has to overgo with that heavy load, not only the deck, then the launching entry is going over. Limited flexibility in the curves, because the length, that makes it very difficult to go around the curves. So you have to have another one different construction technique coming in. So it is not going to be one and all until unless it is straight or having long radius curves. And one more important thing is assembly and disassembly area, because it should be nearby the ROW. Otherwise, it is very difficult. Underslung, yes, it is suitable for lower clearance, you all know. It is also good in curved elements because it's short span curves and you can manage it over by turning few extended cantilevers. But it has got a limited span capacity, not suitable for tall bridges. And also, at times, the ground support, it becomes very challenging when you are going through the massy land. Underslung is very difficult. We were doing a bridge in Patna, and the north approach is giving huge trouble because we adopted for underslung, and then we have to re-engineer the whole process because the ground support condition was very, very, very dangerous. Now, since it is superstructure, there is a tandem lifting, but tandem lifting, yes, this is oversized loads, crane. It requires a lot of engineering coordination. It definitely quite easy because you can get the cranes easily. It doesn't require too much of skills, operators, and their coordination, and the engineers that do it. But it requires a lot of complex planning because logistics becomes a big issue. Second, synchronization becomes very, very important with the operators. Load stability and threat. Safety risk is very high and very long setup time it requires because you have to do the mock, you have to travel, you have to synchronize, you have to see the weather. Now, having been said so more or less you find that the preferred way of erecting anything is going by the gantry, launching gantry or balance cantilever. Because balance cantilever is one thing which gives you enough flexibility. When you go for the launching girder, it is unidirectional. You have to go in one direction. And in case you have any trouble in between with any of the wall, any of the foundation, you are getting stopped. But when it comes of bridge builder, and you have a proper kind of an access, you can have multi-span erections at the same time. You don't have to get delayed because of the unidirectional, either go by front or from two sides. And if you have noticed, we have done the same trick in case of our Dhubri-Fulbari bridge. Initially, we thought of doing with launching girder, and then we changed our approach, and we have opened up 4 fronts in order to see that the project is done on time. Though the investment is quite high, but we retained our stand now. This is full span launching, which we have done now in high-speed railway. This full span launching also, it's a launching girder. I'm covering majority of the launching girders operations. The problem with full span is the full span weight is very high. The full span weight is close to around 1,000 tons. Now 1,000 tons launching is not so easy in normal sense. So it has to got, first it is precast. So in precast area you have to handle that 1,000 ton. Then that 1,000 ton need to be lifted up onto the deck. Then it had to be hauled to the erection location. Then it has to be loaded onto the launching girder, and then the launching girder. So there are a lot of hand shifting happening, and each hand shifting is always a risk. This also has a very high setup cost, and limited to only certain type of bridges because you need to have, like today in navigation channel, you cannot have anything less than 60 meter. So you cannot have a full span. And right now, whatever the designs we have seen across globe, full span is 40-meter restriction as of now. Now I come to another one part which usually not been done across India, the orthotropic steel deck, which was been done in Mumbai Trans-Saharan Link. The OSD's fundamental difference is it has got a bidirectional stress distribution. So when you take the structure, you need to have to create heavy structure. The plates are arranged and stiffened in such a way that it can take X, Y, both direction stress distribution, and it makes it quite efficient because it is very interactive kind of a design, and it improves the load carrying capacity. The picture speaks a lot. Now, why ortho? Why it came in? Why all of a sudden we were doing a cable stay bridge and it became a OSD over there? Now, the fundamentals are this particular path where OSD has been done. This is to take care of the navigation channel for the fishermen. So it has to have a quite wider span. Second very important part, this is a zone where the flamingos usually comes for hatching. Now, if you have a cable stay, it was coming on the way of the flamingo's flight path. So when we talk of modern, the one big important part is environment. One is data science, second is the environment. You cannot ignore it. Now, how do we impact the environment? The construction engineering or construction practices of even present era in India, it has got a tremendous impact on carbon footprint, as well as it is consuming quite some amount of water, which is not very good for sustainability. So earlier we were dealing with skill problem, then faster construction, it came to time problem, then came carbon footprint, now water. So every time when we are going towards modern era, one of the other things which earlier we used to think that we can take for granted, they are slowly coming and showing us that we cannot take them for granted. We have to become a bit conscious about whatever we have been doing. So all the modern techniques, whatever we are doing, if you see here, I'm just taking you through, you can watch the screen. I'm not connecting the screen, so I can. You see that we went through a very huge stretch of natural habitats where there are flamingos, fishermen. You have a very strategic structure of a nuclear plant over there. So it is quite some challenging task how you make those things operational, how you protect the strategic structures which are available there, what kind of things you can do where people cannot take advantage of it. Because exactly on the OSD, if you stand, you cannot penetrate the boundary of the nuclear plant. So a lot of factors it went through. And that is the reason I took initially that all the factors, when we go to modern, we have to consider all the factors. We cannot leave it as it is. These are the quantum of, you can see the volume of work being done over here in order to manage this. It is huge level of coordination. It has been fabricated, this OSD has been fabricated in 3 different countries, and they were never been assembled at that location. They all came to India, and then they got integrated, and then it was launched. So that means the precision engineering, understanding of a drawing, understanding the culture, everything got integrated before making it happen. Because if you have been doing it one particular area, one particular location, the fabrication would have happened, it would have taken another 3 years more in order to construct. So all the available facilities were done together at different. So what I mean to say that logistic engineering also has to come into way of construction, and we cannot leave it. These are a few risks which we undergo usually, and I leave it to you. The last is time and cost, because time and cost is what you can always afford to. These are few launching techniques which are happening across globe, but they are not yet been very popularized. One is the actuator. Whatever you are seeing over here is automatic actuator. So we see that lot of accidents happen during the erection, the installation of the lifting tools. So these are automatic actuators. It just goes down on a remote. You can lock it and you can lift it. So we don't risk any human by doing so. This is once again a long gantry, which is 125 meter it can handle, which is currently not available in India, but they are doing it because this gives a wide navigation channel, and we can still go on doing the precast works without having a bridge builder kind of a support. This is lateral shifting launching gantries, still not available in India. We do it, but we do it in a jugaad method. This is absolutely automated. It lifts, it shifts. But these are not so popular because the cost is high, the engineering is still fine-tuned, and we being a late adopter, we are just watching the first movers and then want to correct ourselves. This is cantilever lifting technique, which is a very nice way of doing things. Using the main structure, the pylon, you start lifting from either side, go on balancing method. This is also one more way which we are observing how the things are happening. Now, before I go to this, I would like to switch to one more zone. Let me just come out, and take you through the sorry for the inconvenience caused. See, this is exactly when we did the OSD. I wanted to draw your attention, because you'll understand then initially whatever I told you, the factors, how these factors comes into play. Every single basics are being calibrated through. Now, while we watch, I intentionally stop the music. Every single thing we do, there are processes, sub-processes. Even if you lift a pen, you first look at the pen, then you stretch your hand, then you put your fingers, and then you lift it. So there are multiple sub-processes. In case of engineering, when we go to modern, all these single processes, we actually now looking out and see what is meaningful, what is not meaningful. If it is meaningful, keep it. If it is not meaningful, eliminate it. If you eliminate, then you bring an alternate. So this is how the whole modern, when we say modern, this is how the modern things are happening. This is also a lean management principle. When I say modern, I think it is, if you look at M is meaningfully doing differently. O stands for optimized resource used. D is delivering the intent. E is environment friendly. R stands for resilient and sustainable. And N stands for nullifying contemporary and contextual risk. If this is the definition we give it to modern, probably all of you over here need not have to listen to people like us standing here. You will be speaking and we will be listening. Thank you all.
Thank you, Mr. Ghosh, for a very excellent presentation on various launching scheme, and specifically that orthogonally placed, anisotropically placed in your OSD and in direction. I thank all the presenters for very excellent presentation. We have 3 excellent presentations on case studies, erections, and 1 on advanced material and new technology. There are few questions, maybe two are important, others are very general observation about excellent presentation. I'll first read out the questions. This is a general question. think it is for both the presenter for the Brahmaputra case studies. Question is about what are the diameter of wells and piles. I think they are already covered in the presentation. What are the type of different superstructure, expansion joint, STU, type of bearing. All are covered. I think I will ask them to briefly again explain the same thing.
Hello. Am I audible, sir? Yeah.
Kindly take the question and answer it.
The first question is, what are the dia of wells? Dia in our case ranges from 10.6 to 11 meters, and foundation depth for wells is 37 meters, and for piles 48 meters and 52 meters on Fulbari side. And the dia of piles ranges from 1.65 meter to 1.8 meters dia. The grade of concrete of different components ranges from M35 for well steening, then M70 for lower pylon, and M60 for superstructure components. Type of superstructure and expansion joints. Expansion joint is a modular strip seal for both viaduct and main bridge. Is there any provision for STU? Our bearings are taking care of it. Type of bearings, we have LRB for our viaduct and disc bearings for main bridges.
In Guwahati Bridge, the dia of well, we have two types of wells, one circular wells in ram portion. That dia is 8 meters, and in main bridge, the wells were double D well with dimensions of 18 by 10 meters. Regarding diameter of piles, in main bridge, the pile diameter was 2.5 meters. In south viaduct, it was 1.8 meters, and in north was also 1.8 meters. Foundation depth of well foundation was 56 meters. Pile foundation in the main bridge was around 58 meters. And in south and north side also the pile depths was around 50 meters. Regarding grade of concrete, in main bridge superstructure, we use M70 grade of concrete, in pylon M55, substructure M50, and in well foundation M40 and pile foundation M35. Regarding expansion joints in the superstructure, we used 8-cell model expansion joint for main bridge. And in viaduct and south flyover also, we used model expansion joints. Regarding STUs, yes, we used base isolation device as I explained in my presentation, which is friction pendulum bearings. And type of bearings was port and PTF bearings. Thank you.
Professor Ravi Sinha, one is question from Madam Tandon.
Thank you. So there is an interesting question. Does Tesla use ABC? So Tesla actually is well known for its cars, of course. But what people don't realize is that Tesla is not a manufacturer of automobile. It is an assembler of automobile. The components are made all over the world at the best possible places for those components, and then they are brought to the factory where they are assembled. In the US, the manufacturing or assembly of Tesla is done in a place known as Fremont. And it used to be a Toyota car manufacturing facility before it was bought over by Tesla company. And Toyota or Japanese companies, they are like the top end of manufacturing methods in North America. So nothing which is more advanced than that. That used to be the thinking. So when Tesla bought over this factory from Toyota, the understanding was that it was already top end. But they discarded most of the processes over there. They developed new robotic systems, got them manufactured and installed over there with new sensors, and now they have taken up to a new level altogether of the manufacturing quality, and which it turned out was essential in order to deliver Tesla, because the design was having much less tolerance to errors compared to the other cars. So the same mindset that you want to deliver better quality, you want to have less error, so you go to the drawing board and then figure out everything else required to support that particular requirement. So in a way, Tesla does show the same mindset and the same planning which is required through ABC for the bridges. So thank you, ma'am, for raising that question.
Dr. Anna, you want to ask some questions? Please. Please, mic near to your mouth. Yeah. Not audible.
Sir, not audible. Please use your mic.
On कीजिए ना. Mic on कर ले. Give other mic. Yeah, that is okay. Please come forward.
Right. Now, please, first these two gentlemen here. Don't mind my asking this because it might be more design.
Sir, not audible. Please keep the mic to your mouth.
Mic नजदीक लाइए ना, please.
Please, now let me talk.
आ नहीं रहा है आवाज.
Thank you. Thank you. I can't help it that this damn thing doesn't work. Only falling short of putting it inside my mouth. Thank you. Now, you called it extra dose bridges, right? And not the cable stay. What is the difference? Cable stay versus extra dose. What's the difference? Why not call it that? I'll tell you why, but I want to know you must have, or your designer must have had a reason.
Yeah, actually, in cable stay, the height of pylons are more, sir. In extra dose, pylon height is less, and also it is supported more by the PT.
No, that's true. But the reason I'm saying this is, if your span range is about 200 meters,
In our case, the span is 125 meters, sir.
and in this case it's 200?
So 200 meters.
Right. If you have a taller pylon, the cables become steeper. So the vertical component of what they can pick up is higher. For the same load, you require lesser stays. Difference in discussion. Plus, in case of cable stay, most of the load goes down through the pylon. In the other case, it goes through the deck. But when you have 200-meter span, have you tried? I'm sure you must have tried. There's a big cost difference if you make the pylon taller, about 80 meters, and reduce the number of pickup points. That is one. Second, in the 50-meter long piles, you have said the diameter is whatever. Construction method was basically what? Board cast in situ?
Yes, sir, board consist.
All the way down to 50 meters?
Pardon, sir?
All the way down to 50 meters?
Yes, sir.
Bentonite?
We use bentonite, yes.
Were the pier segments vertically prestressed to the pier for stability?
Pardon?
Was the pier segment, the pier head segment of the deck,
Yes, yes.
vertically prestressed?
No, it was not integral. We had
any
bearings in
auxiliary
between.
supports?
It was not integral, sir. There was bearing in between.
Sorry?
The pier segment was not integral. There was bearings in between the pier and the pier table.
But did you need any auxiliary supports when the arm extends beyond 30, 40,
Yes,
50
we
meters?
did temporary fixing arrangements, sir. We put PT bars to hold down the structure.
So there was vertical prestressing.
Yes.
That's what I meant. Instead of sheet piling, you did the sheet piling, I understand.
Yes.
So as to be able to do the pile cap.
Dr. Rana, we are running short of time. So
Sir,
please listen me. Please listen me. What is important is that we are running time and the other session also. It is not one-to-one. If you have anything more, please give in writing, and I will request him to reply you. This way we cannot conduct it. Please understand. Because
I have understood all right, but you don't seem to understand.
I have to conclude also, and we are receiving lot of message from the organizer. So we are duty bound to complete the session in time. So whatever you are having, please give in writing. And now I will give my final comments or reservation, and I will close the session. So what is important now, you please listen from my side. So what is happening in India, the design life of all the bridges is 100 years. But if you see what is happening in reality, all the bridges service life is only 32 years.
Sorry,
so
sir.
we have to look. Please.
I have heard you all. You must
No,
listen to me now.
please listen. Please listen. So
Yes,
we have
listen.
to conclude.
Go ahead.
We have to conclude this session. and this way I cannot conduct.
Fine.
Number one. Number two, that this session is followed by some other session also.
Very good. Thank you.
So
Now,
whatever you have to have, please
can
give
I,
in
can I
writing.
reply you for a second? For a few seconds, can I reply you? When you say 100 years, what is the guarantee? Who has lived for
I have
100
not
years
concluded. I have
after
not
designing the
concluded.
bridge?
I have not concluded. I have not a monologue
No,
with
no,
you.
you said 100 years.
I am not on dialogue with you. I am saying
Sir,
what
I'm the
is,
least
what is happening in
interested
the
person
country.
to have a dialogue with you because you don't know what you're talking about.
No dialogue. Please listen, and whatever you want to say, during tea time you can discuss.
Thank you
interact
very
with
much,
me.
but I'm not interested to have a dialogue with you either because I'm talking technical, which is beyond you.
What is happening in India, that we are talking of the resilience even, then durability
Thank
and
you
other
very
things.
much. Carry on and
Why
I'll
it is
waiting.
happening? So it is for the designers and the who
No,
are
no,
constructing.
no.
We have talked to ABC also.
Sorry, I'm
These
sorry.
are the days of.
Okay, I don't give the point.
These are the
Carry on.
days of intelligent
Now
IT.
you are taking time.
So that is what I am
stopped it.
concluding.
I will
am
not speak
concluding.
anymore.
So
There's no
please,
point coming and
organizer, please come back. I have concluded. Session is closed.
Just 1 minute, just 1 minute. I think it was a wonderful presentation by three presenters and excellent case studies. And there are so many related advanced technology of testing, erections, and other things. I congratulate and thanks all the presenters present here on behalf of the session, and ask the organizer to conclude the session.
Thank you, sir. Well, as we come close to the end of the session, I would like to thank our esteemed panel of speakers for the insightful presentation, and would also like to express my gratitude to our honorable chairperson and co-chairperson for successfully moderating the session. Thank you so much. We would now like to felicitate our esteemed panel of speakers on the stage, and to do the honors, may I please request our co-chair, Dr. N.C. Palji, to kindly felicitate our first speaker, Shri Abhiroop Deshmukh, Senior Management Planning, Messrs. L&T, with a bouquet and traditional Aspas gamocha and a memento. Let's have a round of applause from all of you, ladies and gentlemen. Next, I request Dr. N.C. Palji to kindly felicitate our next speaker, May I request our next speaker, Shri Madhav Singla, Manager Projects, Messrs. SP Singla Constructions India Private Limited, to kindly step forward. Let's have a round of applause from all of you, ladies and gentlemen. May I now request our Honorable Chairperson of the session, Shri G. Sharanji, former DGRD NSS Ministry of Road Transport and Highways, to kindly felicitate our next speaker, Dr. Ravi Sinha from Indian Institute of Technology in Mumbai. With a round of applause from all of you. And now may I request Shri Kaushtav Ghosh from Messrs. L&T to kindly step forward. And I request our Honorable Chairperson of the session to kindly felicitate Shri Kaushtav Ghosh. Let's have a round of applause from all of you. May I now call upon stage Shri Sudeep Chaudhary, Additional DG, Ministry of Road Transport and Highways, to kindly step on the stage and felicitate our Honorable Chairperson and Co-Chairperson. Let's have a round of applause from all of you, ladies and gentlemen. I request Shri Sudeep Chaudhary to kindly stay back, and I request our speakers to kindly step forward for a photo op. All our participants and delegates who have not collected their souvenirs can collect it from the registration desk. It is available at the registration desk outside the hall. So I request all those who have not collected to collect it from the registration desk. Before we move on to our next session, we shall take a 10-minute tea break, and I request you all to kindly assemble inside the hall in 10 minutes from now. Thank you. In the meanwhile, I also request our next session presenters to kindly upload their presentation. Shri D. Sarangi, Dr. Sanjay Wakchaure, Dr. G. K. Sahu, and Shri S. Dasgupta. I request you all to kindly upload your presentations. I would also like to inform that after lunch break, we have a panel discussion on sustainability in bridge design, construction, and maintenance with our esteemed panelists. I request all of you to kindly assemble inside the hall in sharp 10 minutes from now. Thank you. Ladies and gentlemen, we shall start off with the technical session 5 in 2 minutes from now. I request all our guests, delegates, and participants who are outside the hall to kindly step inside and take your respective seats. Once again, it's my humble request to all our guests who are outside the